Hello there. This is the chemistry final exam review video number 1. And what you will need is you're going to need a periodic table. You will need your quarter test review problem sheet. We're going to work 1 through 4 in chapter 5. We're going to wait on number 1 in chapter 6 and do that in another video. And we're going to work 2, 3, and 4 from chapter 6 in this video. You'll also need a calculator, so have yours available so you can work along. Alright, and also remember from your packet you have the suggested homework answers. So for chapter 5 I gave you these suggested problems. You can try working through some of those again. Chapter 6, we're going over chapter 5 and some of chapter 6 today. So you have these answers. You don't have to flip through your notes to try to find those. And these would be great if you would work at least some of these, just depending on what kind of grade you want to make. The more you work, the better. All right, let's start with number 1. So it says convert 50 grams of H2SO4 to moles. So we're going from grams to moles. Our major equation in chapter 5, the second part of chapter 5, is this equation, and you'll just have to have this memorized for the final exam. Atoms and molecules to moles to grams. You can go either direction. So in our particular problem here, number 1, we're going from grams, convert grams to moles. All right, so we're starting here at grams and we're going over to moles. Okay, so we have 50 grams of H2SO4. And if we're just going from grams to moles, that's just two sets of parentheses. So we have moles H2SO4, grams H2SO4. All right, when you have moles and something other than moles in a parentheses, okay, whether moles be on top or bottom, doesn't matter. If it's moles and something other than moles, the 1 always goes by the moles. And then to get the number of grams of H2SO4 in a mole, we add it up from the periodic table. So we have 2 hydrogens, that's 2, plus a sulfur, 32.1, 4 oxygens, that's 16 times 4, or 64. So all those 3 numbers added up, 98.1. Okay, rounded to the nearest tenth. So in your calculator, you would do 50 divided by 98.1, and you'll get 0.51 moles of H2SO4. All right, let's take a look at number 2. Okay, number 2 says convert 10.5 moles of NH4 to grams. All right, this time we're starting at moles right here, and we're going over to grams. So it's still just a 2 parenthesis problem. So we have 10.5 moles of NH4 . We're going to grams of NH4, getting rid of moles of NH4. All right, you always put on bottom what you had on the top in the previous parenthesis. The 1 goes by the mole. How many grams of NH4 are in a mole? We add that up on the periodic table. So nitrogen is 14. We have 4 hydrogens. Each hydrogen is 1, so that's going to be 18. So 10.5 times 18, since it's on top, that's 189 grams of NH4. All right, number 3. Number 3 says convert 4 times 10 to the 23rd molecules of C2H6, 2 grams. All right, this time we're starting way over here at molecules. We have to go through moles and then get to grams. All right, so this is going to be 3 sets of parentheses. So we got 4 times 10 to the 23rd. And that's molecules of C2H6. All right, I go from molecules to moles. So moles of C2H6. I'm going to abbreviate molecules, M-O-L-E-C. All right, I know molecules goes on the bottom because it's on the top in the previous parenthesis. 1 goes by the mole. You have to remember this number, how many molecules are in a mole. 6.02 times 10 to the 23rd. That'd be a terrible number to forget. So now we're at moles, all right, and we can go to grams. So let's put the grams on top again. That 6.02 times 10 to the 23rd number will always be beside molecules or atoms. It'll never be beside moles or grams. All right, so we have grams of C2H6. I'm getting rid of moles of C2H6. Okay, again, moles is on top over here and to the parenthesis to the left. 1 always goes by the mole, and here we're just going to add up C2H6 from the periodic table. 2 carbons would be 12 times 2, 24, and then 6 hydrogens would be 6. So that adds up to 30. I'm going to remind you how to put this scientific notation in your calculator. Hopefully you can see this. If not, you can just listen and follow along. But we would have 4, and then don't type in times 10. Do the second function double E. So 4 times 10 to the 23rd. And then we're going to divide that by 6.02, second function double E to the 23rd. All right, and then times 30 on top. That is 19.9 grams of C2H6. All right, and number 4, so this is the last one from chapter 5. If you understand this and these 4 problems, you will be good on the final exam for any question from chapter 5. So number 4 says convert 100 grams of H3PO4 to molecules. Okay, so we're starting at grams. We have to go through moles and then molecules. So there's going to be 3 sets of parentheses. So we have 100 grams H3PO4 we've got to go to moles. So you know the 1 goes by the mole. We need to add up, to get to grams per mole, we need to add up H3PO4 on the periodic table. So there's 3 hydrogens, that's 3. 1 phosphorus, that's 31. 4 oxygens, that'd be 16 times 4, which is 64. So if you add those numbers up, you'll get 98. All right, that's our second parenthesis. And now we have to go from moles to molecules. All right, so I'm gonna abbreviate molecules with as molec of H3PO4. Get rid of moles. You know the 1 will go by moles. How many molecules are in a mole? 6.02. times 10 to the 23rd. All right, one more time, we'll put this in the old calculator. So it's 100. And then we're going to divide that by 98. I hit equals every time. You certainly don't have to. And then times 6.02, second function, double E, to the 23rd. You don't type in any times 10. All right, and that'll give you 6.14. And then you have to read. Sometimes students, I've had a couple of you this year not do the times 10 part. So times 10 to the 23rd. That's a big deal, because that's a lot more than just 6.14. All right, H3PO4 is phosphoric acid. That's an acid you'll have to memorize in chapter 10. Okay, so that does it for chapter 5. We're going to move on. The next one is the stoichiometry worksheet. That's going to get its own video. Okay, so I'm going to do 2, 3, and 4 from chapter 6. So pause the video if you're still writing on this, and we'll move on to chapter 6. All right. So number 2 says a compound has an empirical formula of CH2O. If its molar mass is 120 grams, what's its molecular formula? All right, empirical formula is the simplest form, okay? It is reduced to the least common multiple. So if CH2O is the empirical formula, then the empirical mass, we would just add up CH2O. So for carbon, we would have 1 times 12 from the periodic table. Hydrogen, 2 times 1. And oxygen, we have one of those times each oxygen weighs 16. So that's going to be an empirical mass of 30 grams. Now the problem says that the molar mass is 120. Okay, so you're doing a ratio here. You take the molar mass, or molecular mass, and divide that by the empirical mass, and you'll get a ratio. So that's going to be 120 grams divided by 30 grams, which gives you a ratio of 4 to 1. And to get the molecular formula, then you would take the original, all right, the empirical formula, and you multiply each subscript, right? Don't put a 4 out front like a coefficient. Each subscript you multiply by 4. So that's going to be C4H8O4. All right, so that's how you do that. Hopefully that rings a bell. Let's do number 3. Number 3 says an unknown compound was decomposed into 3 grams of hydrogen, 48.12 grams of sulfur, 95.9 grams of oxygen. What's its empirical formula? Okay, so what you have to do is we have to write out a decomposition reaction. So we have hydrogen, so HX. We have sulfur, so we're going to say that's Y. And then we have oxygen, let's call that Z. So that's going to decompose. Hydrogen is a homonuclear diatomic, right? You have to, for the homonuclear diatomics, there's the 7 that starts with nitrogen, 7 that starts with 7, and also hydrogen. So that exists in nature as an H2. Sulfur is not part of the homonuclear diatomics, so just put S. And then oxygen is, so that's O2. So we have to put the moles in front of each one. We start out with that. So we have to get our moles of H2. And the problem says that we have 3 grams of H2. So we need to convert that to moles. And H2 weighs 2 grams. So that is going to be 1.5 moles of H2. So we're going to put that 1.5 right there. And then for sulfur, it says we have 48.12 grams. All right, and then sulfur weighs 32.1. So that's just from the periodic table, okay? All right, 48.12 divided by 32.1 is also 1.5 moles. And then we have oxygen. Now, oxygen exists as O2, so we have to, we're finding the moles of H2, S, and O2, all right? So not just oxygen by itself. So oxygen is 95.9 grams. That's just from the problem. That's what it was decomposed into. We need to change that to moles. O2 would weigh 32 grams. All right, so that's going to be 3 moles of O2. So that 3 we're going to put right there. So we would have H sub X, O sub Y, S sub Y, O sub Z makes 1.5 H2 plus 1.5 S plus 3 O2. Now these decimal coefficients aren't legal. Does anyone remember what you do to convert those decimal coefficients to whole numbers or integers? I'll give you a second. All right, you divide by the lowest. So divide by 1.5. So that would be H sub X, did it again, S sub Y, O sub Z makes 1.5 over 1.5 is just 1, so H2 plus S plus 2, 3 over 1.5 is 2, O2. So what is X? You just count up that right there. How many hydrogens do we have? It's 2. What is Y? How many sulfurs do we have? We have 1. And what is Z? How many oxygens do we have over here? Well, we have 2 times 2. It's 4. So our formula would be H2, because that's X, S, O4. So that is an empirical formula. If this were not in its simplest form, let's say it was H4S2O8, you would have to reduce it, because this procedure only gives you empirical formula. So make sure you reduce it if on the final exam you get one where it's not in its simplest form after you go through this process. All right, I'll let you pause the video and we will finish up with one more problem. All right, number 4 says, determine the percent composition of each element of C12H22O11. All right, these aren't very hard. You want to be able to do this. Okay, so what we have to do is we have to add all of this up. So the molar mass of C12H22O11 is going to be, so for carbon it's going to be 12, and each carbon, if you look at the periodic table, weighs 12. For hydrogen, there's 22 of those. Each one weighs 1, so that's 22. Oxygen, there's 11 of those. Each one weighs 16, again from the periodic table. And 11 times 16 is 176. So that adds up to 342. So the percent of carbon is, you take the amount that's in the total compound, 144 of carbon, divide it by the total amount of the compound, 342, times 100. Do the same thing for hydrogen. There's 22 grams per mole, so put 22 on top. The entire compound weighs 342 times 100. And then for oxygen, 11 times 6, of this 342, oxygen is 176 of it. All right, and those percentages are 42.1, 6.4, and 51.5. And it should add up to what? 100 or really near. All right, it might be off by a tenth or something really small because of rounding, but it should be really near 100. Okay, so that does it for video number 1. Just make sure that you go back and start working some of these practice problems and extra practice problems. You'll need more. This is a closed note test, so you will need some experience with some of these before the final exam. So work some of these, work some of the ones from number 6, if not all of them. I mean, it would be best to work all of them. And I will talk to you video number 2.